This video is about applying ratios formed by parallel lines and identifying similar figures with overlapping triangles. So, first thing we're going to talk about is the side splitter theorem. So in the side splitter theorem, if a line is parallel to one side of the triangle and it intersects the other two sides, then it divides those sides proportionally. So if we have BD is parallel to AE, then we can say that the two pieces formed by it, so CB over BA, has to be equal to CD over DE. Now, that does not mean the pieces are equal, that just means that their ratio is going to reduce to the same thing. It does not work, though, if your variable is on the parallel side. So if we have a variable on BD and AE, we can't use a side splitter. We have to do what we did in class the day before. So solve for the missing variable. So number one, we're going to solve for x. All of our variables are on the side and not on the parallel side, so we can set up side splitter. So we would have x over 12 equals 15 over 18. So when we cross multiply, we would get 18x equals 180, x equal to 10. So just a faster way of doing the problems compared to yesterday, because in yesterday we would have had to do the entire length of both sides. So this side would have been x plus 12, and this side would have been 15 plus 18, which would have been 33. So if I was solving like we did yesterday, we would have had x over x plus 12 equals 15 over 33. When we cross multiply, we would have had 33x equals 15 times x plus 12. 33x equals 15x plus 180. Subtract 15, so we get 18x equals 180. X is still 10. So either method works, but using the math in the red with side splitter, it's going to go faster. Now, in number 2, we have variables on the parallel side, so we cannot do side splitter. So this time, I need the side from the smaller triangle, which would be 5, over the side from the whole triangle, which is 15, equals the first parallel side of the smaller triangle, which is 7, over the parallel side of the bigger triangle, which is y plus 1. So when we cross multiply, we would have 5 times parenthesis y plus 1 equals 15 times 7, which is 105. So we have 5y plus 5 equals 105. We can subtract 5 from both sides. 5y equals 100. So y is 20. More general with side splitter, and we can use it for parallel lines. If 3 or more parallel lines are cut by 2 transversals, then those 2 transversals are divided proportionally. Now, there's a couple of different proportions we can set up. We can do side splitter, so we can say AB is equal to D over E, or we can do a piece and the whole length. So we could also do AC is equal to D over F, or BC is equal to E over F. It's just going to depend on what variables and numbers you have there to solve. So let's look at a couple examples. Number 3, we have 4 sections here, so each section that's on the same side of the transversal is going to be in a ratio together. So we have 5x plus 1 over 12 is equal to x plus 6 over 14. So when we cross multiply, we would have 14 parenthesis 5x plus 1 equals 12 parenthesis x plus 6. So we have to distribute our numbers, so 14 times 5 is 70x plus 14 is equal to 12x plus 72. So we're going to get x's to one side, so 70 minus 12x would get me 58x. And we're going to subtract 14 from both sides, so 72 minus 14 is also 58, so x would equal 1. In number 4, we need to solve for x, y, and z. So first thing I'm going to do is I'm going to solve for x, because I know that if these four sections will help me solve for x. So if this whole side is 32 and part of it's 20, we can subtract to get 12. So when I'm solving for x, I would have 12 over 20 equals x over 16. So when we cross multiply, we get 20x is equal to 192. So when we divide by 20, we get that x is 9.6. Then we can solve for y using the bottom four sections. So we would have 20 over y plus 15 is equal to 16 over 14. So when we cross multiply, 16 times y plus 15 equals 20 times 14, which is 280. We can subtract, or we can distribute the 16 to both things with parentheses, so 16y plus 240 is equal to 280. We can subtract 240 from both sides, so 16y equals 40. So y is 2.5. Then because we know that x is, we can use the top four sections to solve for z. So we would have z plus 5 over 12 is equal to z plus 3 over 9.6. So when we cross multiply, we have 9.6 times z plus 5 equals 12 times z plus 3. So we can distribute, and we would have 9.6z plus 48 is equal to 12z plus 36. So we can subtract 36 to both sides to get 12, and we can subtract 9.6 from both sides, and we get 2.4x. So when we divide 12 divided by 2.4, we get x, or we get z is 5. So let's take a look at two review problems. So the first one is dealing with our similar triangle. So number 5, we have 3 triangles. So we're going to redraw these triangles. So we have 3 right triangles. We have the original right triangle, and then the 2 smaller right triangles. Now remember, with the 2 smaller right triangles, we want to label that H is congruent and J is congruent, so that it will help us labeling our new triangles. So the first triangle is going to keep the original, so H is the top angle, I is the right angle, and J is the bottom angle. Then if I look at one of the smaller triangles, we see that H is repeating, has the same congruency mark, so we're going to put H at the top. The new right angle is going to be K, and so the leftover angle would be I. And then for the last triangle, we see that J is in the same spot, so it's going to go in the bottom of the triangle. I is the right angle. Nope, K is the right angle, so I has to go up top. So remember, I should end up in all 3 places. So we would have HIJ is similar to HKI, which is similar to IKJ. Then we can label what we know. So we know that HJ is 8. We know that HI is Z. We know that IK is Y. We know that IJ is Z. Nope, we know it's X. And we know that KJ is 2. And if the whole side over here is 8 and KJ is 2, this leftover part is 6. So now I can solve for my variables. So when I'm solving for each variable, I want to find which 2 triangles have the letter. So to solve for x, the first triangle and the last triangle have x. So when I solve for x, I would have x over 2 and 8 over x. So we have x over 2 equals 8 over x. Cross multiply, x squared equals 16. So x is 4. To solve for y, The second and the third triangles both have y. So we would have y over 2 and 6 over y. So y over 2 equals 6 over y squared is equal to 12, so y is the square root of 12, which simplifies to 2 root 3. And then the last one for z is in the first two triangles, so we would have z over 6 and 8 over z. So we have z over 6 equals 8 over z, so we get z squared equals 48. So we take the square root of both sides, so z equals the square root of 48, which is 4 root 3. Number 6. Triangle ABC has the coordinates A is at 0, 0, B is at -2, 4, and C is at 6, 6. Then we need to multiply by a scale factor of 3 over 2, which means our triangle is going to get bigger. So when I do that, my new P coordinate, when I multiply the B's, I would get -3, 6 for my new P coordinate, and R would have the new coordinate of 9, 9. So now I need to prove that these triangles are similar. So when I'm proving the triangles are similar, remember I want to see if there's any angles that repeat. Well, A is in both triangles, so we can say A is congruent to angle A by the reflexive property. Then to get one of our other angles, we need to find parallel lines first. So I'm going to find the slope of BC. So BC, we went up 2 and over 8. So that slope would be 1/4. PR, we went up 3 and over 12. So that's also 1/4. So because they have the same slope, that means the lines are parallel. So we can say BC is parallel to PR because the lines have the same slope. Then because those lines have the same slope, we can say that B is congruent to P. We could also have done the other two angles. So we say B is congruent to angle P because if lines are parallel, then corresponding angles are congruent. Now that we have two sets of angles that are congruent, we can say the triangles are similar. So triangle ABC is similar to APR by angle-angle similarity.